Now we're going to keep going with binomial. There's some other things we need to know about binomial. Again, we're going to go over the bins thing again. Excuse me, we're going to go over the bins thing again, and we're going to go over the calculator stuff again, because again, calculator is how we're going to do this. So here's what we got. We got a pop quiz. That's what we did in class. What we're going to see is this is another binomial setting, but let's do the practice on the back. Are you more likely to win a random drawing if you crinkle the paper that contains your name before putting it into the drawing box? A curious student conducted the study to investigate. The student took 100 equal size slips of paper and crinkled 25 of them before putting them all into a box. After mixing well, they asked an uninformed person to select a winner at random. The student noted that if the slip was crinkled, the slip was returned to the box. Noted the slip was crinkled. The slip was returned to the box, mixed well, and asked another uninformed person to select a winner at random. This process was repeated 10 times. Let y be the number of times crinkled paper was selected. Is this a binomial distribution? We'll go quickly through the bins thing again. Is binary? Yeah, it's binary because it's crinkled or it's not crinkled. So there's my B. So my success is crinkled, my failure is not. So this is my success. Crinkled would be considered success, not would be considered a failure. Independent. Yep, it was returned to the box. So there's independence there. Do we have a fixed number of trials? In this case, we're repeating the process 10 times, so n is 10. And in this case, we're looking at our success probability. Does it remain the same? Yes, our probability is 25 crinkled pieces out of 100. So my probability of success is 0.25. So what we're going to look at here is we want to try and figure out our mean and standard deviation. I'm going to hold off on using the technology of the probability distribution. We're going to come back to that, but I'm going to talk about the mean. And the mean of a binomial distribution, it's on your formula sheet, is n times p, your number of trials times your probability of success. So in this case, it's 10 times 0.25. So in this case, where I'm going to say is the answer here is 2.5. And what I'm going to say is after many, many trials, and a trial being picking out pieces of paper of size 10. So again, what this is mean, any trials of size 10, so I do this thing 10 times. If I do it over and over and over and over again, picking out 10. The average number of wrinkled papers, the average number of wrinkled papers is around, number of wrinkled papers drawn is around 2.5. So it's saying that over in the case, the average over long periods of time, doing this 10 times, I would expect the average to be 2.5. For my standard deviation, again, these are both on the formula sheet, so let me actually show you. So you got your formula sheet, this is your front page of your formula sheet. Right here at the bottom is where we got the binomial distributions mean and standard deviation. So the standard deviation here of this distribution y of a binomial is the square root of the sample size times the probability of success times the probability of failure. So in this case, it's going to be 10 times 0.25 times 0.75. And if I go to my calculator, I can figure out that's 1.369. The interpretation, the number of crinkled papers selected in a set of 10 typically varies by 1.369 pieces. What they're called paper slips from the mean of 2.5. So that's our mean and standard deviation. Again, it's a formula on the formula sheet. It's a plug and chug kind of thing. Again, this is going to consider your work. This is going to consider your work. And then you're going to go to your calculator. So if you want to see what the technology does, I'm going to tell you, I'm never going to ask you this, but just in case, for thoroughness sake, the way we're going to do this is So if you think about it, we're going to go to stat, we're going to edit. If you think about this, when I play this game, here's all of my outcomes. I could have 0, 1, 2, 3, 4, 5, 6, 7, 9, or 10. I could have any one of those numbers as successes. And the way I'm going to figure it out is I'm going to put the binomial PDF in here. So what I'm going to do is second vars. And I'm going to go in and put in binomial PDF. And the trials are going to be 10. The probability of success is 0.25. I'm going to take the X values from my L1. And that's going to give the probability of exactly each one of those successes. So when I do that, if I look at this, all these numbers are going to actually add up to me to be 100%. What I want to do is I'm going to make a histogram off of L2. So I'm going to do second Y for stat plot. I'm going to turn it on. I'm going to want to make a histogram. I'm going to make it off of my L2 because that is where my probabilities are. And I'm going to zoom 9 it. And what that's going to do is that's going to give me a rough idea of what that probability looks like. Again, I'm not ever going to make you do that. So let's not even worry about that. I just want to kind of show you what it looks like. Really, the most likely outcome is going to be everything's going to be kind of centered around that 2.5. So that's binomial setting. We're going to come back around to it. We're going to practice it a little bit more. Again, use your daily reflection to give me some feedback on that if you have any questions. We will kind of build off of it next class, a little bit of more binomial setting, and then we'll pick up with geometric setting, which is the other